Hello, and thank you for joining me for another episode of Empower Apps. I'm your host, Leo Dion. Today, I'm excited to have Leah Vogel on to talk about Bluetooth. Hey, Leah, how you doing?
Hi, I'm doing great, Leo. Thank you. And yourself?
Good. I'm enjoying this warm weather here. I don't know about you, but it's nice to have the summer here finally. Before we get into our topic for today, Bluetooth, could you tell us a little bit about yourself and what you do?
Sure. Well, I'm currently the mobile team lead and an iOS developer at a company called OrCam Technologies, and we're based out in Jerusalem. So, in short, I'm an iOS developer and a team leader. What do we do there? OrCam develops smart assistive devices. The flagship device that is most well known for is called the OrCam My Eye, which is for visually impaired people, and it helps them become more independent and be able to interact better with their environment. And we have a new device coming out soon called the OrCam Hear, which is an assistive device for people with hearing impairment. And so basically, we work with a lot of smart devices. And being a mobile developer, so how do we come into that? Is we have the companion apps that interface with these devices using Bluetooth technology.
Cool. How reliable is Bluetooth technology for a lot of this stuff?
Well, it depends what you mean by reliable. I'm happy that I work in a field that uses assistive devices rather than like life saving devices. Although I think it would be really cool to work in med tech with the devices like a continuous glucose monitor and whatnot. There's a lot more pressure of having perfection over there because there's certain things that you can't miss.
Right, exactly.
So when I'm saying that, you can hear that there's a little caveat about Bluetooth. It's not 100% reliable. There are ways to make it more reliable. There's different ways you can set up your communication to require a response from the other side, et cetera, to ensure more data integrity. But the connectivity in general, it has its challenges.
I'm sure we'll get into that as we talk more. One thing I wanted to ask, so I've done a lot of Bluetooth with like exercise machines. I played around with like reading battery information, things like that. What's really interested me is kind of like what the history is behind Bluetooth and where it came from.
So one of the things that I find funny is Bluetooth is a technology. It's a word that most people are familiar with and they know what it does, et cetera, et cetera. And even me myself, until recently, I never actually thought about where did it get its name? What is Bluetooth? What does that even mean? So I read up a little bit about the history of it. And Bluetooth technology actually has been around since around 1996.
Okay.
And there were a few companies working on it at the same time. They were all working on some kind of solutions. Nokia, Intel, and Ericsson, they were all working on their own kind of short range radio technology solutions. And so when they found out that their competitors were working basically on the same technology, they decided instead of competing that they would all bond together. And they formed something called the Bluetooth SIG, the Special Interest Group. And this special interest group was formed back in 1998. So what happened is like Jim Kardak from Intel, he was one of the people working on the Bluetooth technology, and he went out for drinks one day with Sven Madison from Ericsson, and they were just discussing about things they had read recently. And Sven was speaking about a very interesting book that he had read about Vikings, and so that inspired Jim also to read a book about Vikings. And one of the Danish kings, he was actually the second king of Denmark. His name was King Harald Bluetooth. And he was famous for uniting Scandinavia. So he united Denmark and Norway. And this is way back in the 10th century. It was in the year 958. So Jim really identified with King Bluetooth. He's like, wow, this is basically what we're doing here. We're trying to connect the PC and the cellular industries with this short range wireless link. And so he codenamed this project Bluetooth, and that really wasn't supposed to be the official name. Actually, the name that was supposed to win was called PAN. PAN was stood for Personal Area Networking, and that was the proposal that IBM gave. And shortly before the release of the technology, about I think it was like a month before, the legal team said, "Hey, we've got a problem here. We can't trademark the name PAN. It's too broad. It's too well known. There's too many other uses for it." So they decided they were going to fall back to their second choice, which was the Intel proposal called radio wire. But there really wasn't enough time to check feasibility for trademarking that either. And that is actually how they wound up using the name Bluetooth, which was the code name all along, as the final technology. And the marketing team who was responsible for getting the word out there was actually really excited about the name Bluetooth because it was something new, it was something interesting, and here we are all these years later, and it's still there. There we are with the Bluetooth.
I'm wondering if there's like any old marketing information that still has pan or like the other term, like Bluetooth headsets and things like that, because they changed it so quickly. Because I know I've seen pan before, but I've never seen
Radio wire?
I don't believe I've never heard of radio wire before.
Do you know that one of the proposals was actually called Flirt, and the tagline was "Getting close but not touching"? That was a real proposal.
Wow. I'm glad that, yeah, Bluetooth is a better choice.
Yeah, can you imagine if you have a Flirt headset? I wonder how that would have washed.
Yeah, exactly. So Bluetooth, I like that name a lot. Like, let's get a little bit into the terminology used. So I started playing around with the core Bluetooth framework, and there's a specific terminology used in Bluetooth for various things. So what exactly, let's start off with peripheral. What exactly is a peripheral?
Okay, so there's different roles when you want to start using Bluetooth. And I'm going to speak more probably about Bluetooth low energy because that's what I'm more familiar with. But the different roles that the players can have are basically a central role or a peripheral role, where the peripheral is really, if you consider the master-slave relationship, so the peripheral would be the master because
Okay.
it's the one that contains the information. It's the source of truth. And like the server, the central being in this analogy, the central would initiate a connection to the peripheral and then send requests to it in order to get information. So if we could think of an example, like you were saying fitness before, let's say we were talking about a heart monitor. So the heart monitor itself, that would be the peripheral because it's the one that has the source of truth. It has the information. It has all of the readings that whoever wants to subscribe to will be getting from. And it will communicate in one of many different ways to either other peripherals or to central. One of the things about Bluetooth low energy is there's different communication paradigms. You can have like a point-to-point connection where, like I said before, like you have a central that initiates a connection and it kind of like pairs to this specific peripheral. You can also have a peripheral that is broadcasting, and then anybody who's listening can subscribe to it. Like you can imagine like the iBeacon technology when they were using Bluetooth, and it would just broadcast its information and whoever was listening to it could get the information. And then there's another type of communication called mesh networking, where it's a many-to-many connection where peripherals can all communicate with each other. And that really enables a very long range of communication because you can get the same information from device to device without having to be in such close proximity.
So there's an app I've used called BlueSea BLE Debugger for doing development. Are you familiar with that app?
I'm not specifically, but I know that there's an NRF Connect and there's Light Blue. There's a few of them out there.
Yeah, so you can kind of see in an app like that, if you want to know, like, what does subscription mean and things like that, like some of the terms that you were using and understanding how you could subscribe to the data of various peripherals. One thing I've seen is the term services. What exactly are services then?
Okay, so how do the Bluetooth devices communicate with each other? One thing that's really interesting is the special interest group, when they formed the protocol and how they want to communicate with other devices, it's very strictly adhered to. If you want to communicate, you have to set up your characteristics, and we'll get into what that means, all in the same manner, and that way everybody knows how to communicate with each other. So how does this work? So basically, we have something called a profile. A Bluetooth profile is kind of like a list of services or a purpose that this device wants to adhere to. And a device could have more than one profile as well. For instance, you could have a health device that has a specific health profile, like let's say the heart device, right? So we have the heart monitor profile. There's actually a profile about heart devices, and maybe it also has a device information profile, etc. So a profile encapsulates like a list of channels that you can communicate or query the device about. So inside the profile, you'll have a list of services. The services encapsulate a list of characteristics, and each characteristic can have one or more optional descriptors. So let's talk about what all these different things are. So we have a characteristic is the actual channel of communication between the devices. This is actual how you're going to be communicating with each device. So when you want to connect to a Bluetooth device, you scan for devices that have certain services that you're looking for. So if you can imagine you're in a room with lots of Bluetooth devices and you're interested in connecting to your earphones, you're not interested in your friend's heart monitor, and you're not interested in your child's little drone, you want your earphones. So when your phone, for instance, that wants to connect to your earphones is scanning for those earphones, it's looking for a device that is advertising a service, let's say an audio service, right? So you have the different roles of the central and the peripheral. So the central is the one who's scanning for the devices that are advertising service information. So as soon as...
And that would typically be the iPhone, right?
Not necessarily. Of course,
Okay.
if you're an iOS developer, it's going to be the iPhone. But you can also do it from your computer. Your computer is also is Bluetooth enabled. You can make Bluetooth apps.
Right. I'm just saying as an example.
Oh, as an example, for sure. Okay. So let's say my iPhone is now scanning. Let's take an example of the heart monitor. So my phone, I have an app and it is a reader for the heart monitor. So I'm going to be scanning for devices that are advertising the heart service. Now, a device, the heart monitor could have lots of services on it, but it doesn't have to advertise all of its services because it advertises something called, it has an advertisement dictionary, and you don't want to advertise a lot of information at once. So it'll advertise whichever services it wants to make public. And then devices that are scanning and want to connect to ones with that service, once they discover, right, they find the device, they connect to it, and then they can discover all of its services. So just because it's only advertised one doesn't mean that they won't be able to discover all of them. Now, it could be some of the services I'm not interested in. Maybe my heart app is not interested in the fact that the heart monitor also knows my temperature. I don't want to display temperature. So even though it has a temperature service, I don't necessarily have to read it or communicate with it if it doesn't interest me. So once you discover the services, then you can discover each service's characteristic. And again, just like you might not be interested in all the services, you might not be interested in all of the characteristics of a specific service. But once you discover the service and discover the characteristics, you are now free to start communicating with the device using these channels of communication.
So one thing I've been interested in scanning is devices with battery information. Was that a service, a characteristic? What exactly would I be looking for?
You probably will be looking for a battery characteristic, although depending on the device, it could have a battery service.
Oh, interesting. Okay.
But once you want to actually read the information, that's always from the characteristic.
Okay.
Now, what's interesting about characteristics is there's different kind of properties. They could be read, they could be write, they could be read-write, they could be notify, and they could be indicate. So when we were discussing before about the reliability of Bluetooth communication, so you can actually set, you meaning the peripheral. The peripheral can say, okay, I have a service. This heart service is very important, and I want my characteristic to have the property of indicate, which means anytime I send a packet of information to somebody who's subscribed to this information, I want to receive confirmation that it's been received. I want to get a ping back. So that has its pluses and its minuses. First of all, it slows down communication because you're not free to send the next package until you've received a confirmation that you got the previous one. So it slows things down. It also can take toll on the battery. But if your data is very important, then that's something that you have the option to do. Notify, like when we were talking about the battery characteristic, but that might also be something that you want indicate. For instance, if you're using a life-saving device, if you're using a glucose monitor, you also might want to have indicate. Notify means that anytime this value changes, the peripheral will notify all of its subscribers. It doesn't need to be a request response mechanism there. It just notifies, it broadcasts over the channel of the characteristic, the new value that it has. So when you discover the services and you discover the characteristics, part of the core Bluetooth framework is you can set the characteristic if you want to be notified about it or not. So if you're playing around with the battery services, you probably want to set notify, and then anytime the battery is changed, you're going to get an automatic update.
Interesting. Okay. One thing you've mentioned is that your specialty is in Bluetooth low energy profile. Is that correct?
Yes.
What does that mean exactly? How does that differentiate from other types of Bluetooth?
Okay, well, there's basically, I'm going to make it in very broad terms. There are two types of Bluetooth. There's Bluetooth, the classic Bluetooth, and Bluetooth low energy. And classic Bluetooth has a few different types. The very first type that came out was called BR, the basic rate Bluetooth. And basic rate Bluetooth, the first core specification was in 1999. And it the transfer rate was 1 megabit per second.
Okay.
And then in 2004, a new kind of Bluetooth came out called enhanced data rate, EDR, which then became between 2 and 3 megabits per second. So that was a big step up. So when you hear about classic Bluetooth, then it could be referring to either BR or EDR, basic rate or enhanced data rate. And then came along with Bluetooth low energy. So what is really the difference between Bluetooth low energy? Why would anybody want Bluetooth low energy? First of all, its transfer rate is generally a lot smaller than Bluetooth Classic. So what is its selling point? Why is it such a good thing to have? So it does open up a whole bunch of other options. The low energy, as its name says, has power conservation built into the way it works. What it does, it has a mechanism that kind of puts it into sleep mode. So when it's not transferring data, it's really not using much power at all.
Wow,
And then
cool. Okay.
when it needs to transfer energy, it wakes up, it transfers its energy and goes back to sleep. So the use case for Bluetooth low energy and Bluetooth Classic is a little bit different. Bluetooth Classic always maintains its connection, even if you're not transferring data. But that's really important for something, let's say, like audio streaming. Like headsets in general are classic Bluetooth.
Interesting.
They have a
Okay.
high transfer rate and they're reliable, but they also are more expensive and their battery drains quicker. Whereas the low energy, the purpose of them is usually for smaller chunks of data to be transferred. It could still be very frequent, but the fact that it's smaller chunks, that makes Bluetooth low energy a good candidate. They do have so if you want to like compare about the power consumption between the two, if we take the Bluetooth Classic as the reference unit, so let's say it uses one reference unit, so Bluetooth Low Energy uses between 100th up to a half of that reference unit. So it really has a big edge on power. So if your battery life is really important, Bluetooth Low Energy is definitely a better choice. If you have a device that's going to be plugged in all the time, then it really doesn't matter. You can use whatever you want. But when it's something like wearable technology or IoT devices that aren't necessarily going to be having their batteries changed so often or whatnot, then Bluetooth Low Energy becomes a very good choice.
Yeah, that makes total
Whether
sense.
it's because of battery and also because of cost. Bluetooth Low Energy is a cheaper technology.
So I've seen the term RSSI. Is that synonymous to signal strength?
It is signal strength. It's radio signal strength.
Okay.
What is the I? I know this.
Indicator information.
That's right.
Something like that. Okay.
The RSSI is the received signal strength indication. That's what it is.
Okay.
And RSSI is, of course, the better the signal, the better information you're going to get. And the way it works, the closer to zero, it's usually measured in negative numbers.
Right.
And the closer to zero is the better power. So when you get around to like minus 100, then you really don't have very good range. But anything, up to like minus 60, it's pretty good.
Okay.
That's pretty good.
And it's probably some sort of logarithmic mathematics to calculate that, I would assume.
Probably.
Yeah.
That's actually one of the differences that core Bluetooth framework from iOS has undergone. It used to be that RSSI was read in a different manner. Now, if you want to query RSSI, you actually have to send a request to get the RSSI.
If you want your app to succeed, there's never been a better time to read up on App Store optimization. And AppFigures provides that just for you. As I've mentioned before, they have all these great articles and guides on App Store optimization, and you can check them out and help improve your ASO. Lately, they've also started doing teardowns of specific apps like Spotify, for instance, and show exactly how they're utilizing ASO to get the best possible download results. You can take a look at their resources page at appfigures.com/resources. You can also take a look at the link in our show notes below. Try AppFigures for free, and if you like it, Use our special code EMPOWER3030 to get 30% off for the next 3 months and increase your download numbers. Again, use our special code EMPOWER3030 to get 30% off for the next 3 months. Thank you, App Figures, for sponsoring our show. So we talked a bit about characteristics. Now, each characteristic has like multiple, what seemed like called descriptors, correct?
Yes.
So how do those exactly work?
Okay, so a descriptor is an optional. First of all, it's an optional thing. Not all characteristics have descriptors, and a characteristic can have 0 or more descriptors. So what a descriptor is, it's basically like a little bit of extra information about that characteristic. So if we have, example, a temperature monitor, so a descriptor could be whether it's in Celsius or Fahrenheit. Or a heart monitor, it could tell you the minimum or the maximum and stuff like that. So descriptor is just like a little bit of extra information about that characteristic.
Got you. Okay. That makes sense.
Mm-hmm.
So when you're working specifically on on iOS or Swift and you're getting the data back, it sounds a lot like a network call in a lot of ways, based on the way you're describing it. You get back essentially binary data, right?
Correct.
What are some like good patterns and practices for decoding that data? Like typically on the web, like it's easy and nice because all you have to do is like decode it from JSON, right? But we don't get that convenience in Bluetooth. Like, what are some good patterns and practices for decoding that binary data?
Oh, I wish I had thought of a really good answer for this one, but when I started working with Bluetooth, that was the first thing I had to do, was actually to write a parser for the information that we were getting back. And it was complicated. It was complicated because, first of all, you had to make sure that your convention that you had with the other side, right? In my case, it was with the device, that it's being adhered to. Like, as you said, with the web, you have your JSON and there you go. But here, we have like this whole contract between us that the first byte will be this and the second byte will be that. So it was really very custom. And then we have a part where we actually have the body of the response. And then, yeah, I had to decode it as data, and then just knowing the different types. The same way you eventually want to decode your JSON data, you do at the end of the day have to know what your types are.
Right.
So here also we had to define the types and yeah, so that's kind of code that I wrote 3 years ago. Wrote it once, it worked, and I haven't looked at it since.
Yeah. Are there any good like testing patterns for something like this to make sure that it works without necessarily needing an extra Bluetooth device, if you know what I mean? Especially if you're doing like unit testing.
Right. So one of the interesting things that you need to know about when you're working with core Bluetooth is the fact that it doesn't work on a simulator. So if you don't have an actual device to work with, you have to mock your own data. So that's what I would suggest that you do, is that when you write your code for parsing your messages, that you mock it. You gotta fake it till you make it.
Right.
You have to start with something and hope when you get to integration that the other side has kept the contract. And as you know, being a software developer, that never happens.
Right. But yeah, that's one of the things that would make a lot of sense, and I've run into is like, yeah, simulator Bluetooth does not work, obviously.
Right.
Or you end up writing, I mean, you could kind of, I guess, write a Mac app that shares code. Exactly.
We actually did that. We do have a simulator that we wrote for the Mac in order to communicate with our apps, just to see, it's different writing a unit test to decode data or actually testing a whole end-to-end flow. And sometimes you really need the flow if you're let's say you have screens that are, let's say your onboarding is based on connectivity and pairing and whatnot, and sometimes you just need things to work as expected in order to really test them. So yeah, we did write a simulator app for the Mac. That is also definitely an option, although trying to keep it up to date is a challenge. It's kind of like writing documentation, so when things change, you have to remember to update the documentation, and updating the simulator is a whole challenge in itself.
Yep. Yeah, I can imagine. What are some other like common issues you've run into when you're developing using core Bluetooth?
Well, I would say connectivity is probably the biggest, is that whether it's disconnections or just not being able to connect, There have been some challenging releases of iOS that really had a lot of connectivity problems. And you always wonder, oh, is it my app? Is it the device? What's going on? It's sad if it ends up being iOS because there's not really much you can do about it. So I think the biggest challenge has been connectivity. Back when I first started working with Bluetooth, I had worked previously in a company where we were developing a smart band for the Apple Watch with a camera, and it was also using Bluetooth, and that really wasn't anything I had to deal with because I was working on the higher levels of the UI and external communication. And when I started this new position and I had to really get into the bits and bytes of the Bluetooth, there were some unexpected things that happened when I started using the core Bluetooth framework. For instance, there's a delegate method for when the peripheral that you're trying to connect with either connects or disconnects. But there's another thing that can happen is the whole state of the central manager. That's the object that you use when you're using core Bluetooth. Is you instantiate a central manager when you want to be the role of the central and connect to peripherals. So if your central manager all of a sudden becomes disconnected, let's say the user turns off their Bluetooth, you can wind up in some weird states. If you've made like a request to your peripheral and you're waiting for a response, and let's say your UI, you're showing a spinner and your response just never comes because the state changed. So there's things that you had to take into account that aren't necessarily intuitive.
Yeah, that makes a lot of sense. So, like, it really does sound a lot like networking stuff, where it's like
Hmm.
you need to be able to handle error states because they're going to happen. It's inevitable with just any sort of apparatus where you're using multiple devices where something can fail that has nothing to do with your programming.
Right.
You need to handle that so your app doesn't freeze, essentially, because that's the
Correct.
worst case scenario. What other stuff have you done with the Apple Watch as far as Bluetooth is concerned?
Well, I haven't worked with the Apple Watch for a long time, and it was actually exciting to see the interesting things coming out now from WWDC. But the interesting things that I worked with the Apple Watch, well, when I worked at Glide is a video messaging application, and we had an Apple Watch app where you could consume live video messages on your wrist. So that was cool.
That is pretty awesome.
Yeah, and then when Glide started working on the wrist cam, which is the that band that I mentioned before, yeah, we did some pretty cool things with the watch. I got to do so again, I said that the wrist cam is basically a camera for the Apple Watch inside of the band. So you could now directly take pictures and videos from your wrist. And I worked on, for instance, live streaming to YouTube, live streaming to Facebook, posting from your watch, taking a picture and posting it on Twitter. It was really cool.
Yeah, that is pretty awesome. Yeah, I've done some work with the Apple Watch as well. But so it's interesting. I'm curious what kind of battery life they'd get on the camera if it's because I would assume it's pretty small, correct?
Yes, it is pretty small, and the obviously the band has its own battery, so it's not stealing any from the watch.
Yeah, that is pretty
Although
sweet.
it might be a good idea to steal some from the watch. The Apple Watch has pretty good battery.
Yes. Yeah, it's pretty amazing how they keep updating the hardware on the Apple Watch.
Yeah.
So you're talking a bit about central manager. We have that delegate you have to set up when the
Hmm.
state changes, like power off, power on, disconnect, things
Hmm.
like that. What are some other things that people have to consider when it comes to connectivity?
So here's something interesting that you probably wouldn't think about is your peripheral could already be connected to your phone when you're trying to connect to it through your app. For instance, let's say we're talking about. I keep going back to the example of a heart monitor, just because it has all different ways that you could interact with it. But let's say the heart monitor is connected to my health app in my iPhone, right? And I'm writing my own custom app that I also want to interact with this heart monitor. So when I go to connect for devices and I start saying scan, I'm not going to find the heart monitor because the heart
Oh,
monitor isn't
interesting.
currently going to be advertising that it wants to be paired with because it's already paired with my phone. So it wouldn't even be in advertising mode. So I won't find it on a scan. So there's like a few different paths you have to consider when you're connecting to the devices. So the first thing you would want to do is If you've already connected to your device previously, it's a good idea to store its UUID. Every time you discover a peripheral, which is one of the delegate callbacks that you mentioned with the central manager, so you get a UUID. Each peripheral has an identifier, and it's a UUID. So I recommend you store that if you're going to want to connect to the same device again. So the first thing you'd want to do is you'd want to search for that peripheral and try to connect to it. And if you can't connect to it directly, then the next thing you want to do is see if you have any devices that have the services that you're looking for that are already connected to your phone. So you're going to want to try to connect to one of those. So if you have that service, then if it's already connected, and if not, then of course you want to go to scanning and hope that your device is going to be advertising. Now, advertising is funny because we talk about Bluetooth Low Energy, and the device doesn't want to be in advertising mode all the time because it drains the battery. So some devices require that you do things in order to put it into advertising mode, whether it's pressing a button or like when you have, do you have AirPods?
Yes.
Like, so if you want to pair your AirPods. You
have to open the case?
Right, you have to open the case. So that causes it to start advertising. So that way your phone can pick it up. So you have to know what your device does in order to advertise. So interestingly enough, at work recently, we had something funny happen. So one of the devices we were working with, in order to make it advertise, you press a button. And we have another device that we were using in development, had the same form factor. And for some reason, I couldn't get it to advertise. No matter what I did, I pressed the button, nothing's happening. And it turned out that in order to get this device to advertise, you had to turn it upside down. So the orientation was what caused it to advertise. So
that's not very intuitive.
No, I didn't think so either.
I want to talk a little bit about pairing as well. So pairing is the idea of like a device always connects to another device. And so that way, like for instance, especially with headphones, like you don't want to be able to have like somebody else's iPhone play on your Bluetooth headset, correct? More or less?
Right.
Are there devices? One thing I always look for are devices like speakers or phones that allow for multiple pairing. Is that just not a thing?
Well, it depends on the type of device. If it's a classic Bluetooth device, I don't think you can connect to more than one, pairing connection. Whereas BLE, you actually can. If you talk about the whole pairing process, what happens when you want to pair with another device? So what happens is the devices exchange some data about their different capabilities, and they each generate a key that they can be identified with later, and they exchange these keys. That's like the most basic pairing stage. And then there's like a more secure kind of stage, which is called like it's bonding and it's optional. Then you can generate a key to verify the other one's identity for a future connection. So it's not just like this connection, but it's for future connections as well. So that's how they know how to identify each other. They have these special keys. And sometimes like that's also one of the things that you encounter a lot when you're developing in Bluetooth is all of a sudden, your device is just not communicating anymore, even though your phone knows the device. If you go into Bluetooth and you see your list of devices, your known devices, you might see it there, but it's still not connecting. So different things can happen. So whether it's the phone that lost the keys or the device itself changed the keys, sometimes during an update, like the device updates or the phone updates, then something gets messed up with the keys. So sometimes you actually have to go into the Bluetooth and go to the device and go forget. You tap the little information, you forget the device, and then that deletes the local keys that it's stored, and then it allows it to repair when you want to do the pairing process again.
Okay, that makes a lot of sense. So one thing I wanted to ask about is like how Apple uses Bluetooth in a lot of interesting ways. So one of the things that Apple talked about recently at WWDC is the use of their new, is it like U1 chip? Yes. In the iPhone 11 and how that uses like wideband stuff for nearby interaction. Have you looked into that at all?
Well, I did look at the WWDC session about it. Of course, as soon as the list of the sessions came out, the first thing I look for is Bluetooth. What are the Bluetooth updates? Not that I was expecting anything major, although I wasn't expecting anything major in iOS 13, and there was something major. The major thing that they released in iOS 13 was that now iOS supports, the core Bluetooth framework supports connection with BR/EDR devices, which was never available. When iOS came out with the core Bluetooth framework back in iOS 5, it was specifically BLE. BLE meaning Bluetooth Low Energy. Actually, there's something I want to note about that. When I was preparing to speak about Bluetooth at UIConf, I actually sent an email to Bluetooth.com requesting the use of one of their graphics. And I must have said something in the body of the email using the term BLE. And that's something we say at work a lot. We always say BLE, which is Bluetooth Low Energy. And I was corrected that you do not say BLE. It's called Bluetooth LE, and please not to use BLE. So I apologize for saying BLE, and let me go back to what I was saying. So iOS 13 released support for BREDR, the basic rate and enhanced data rate, which was Bluetooth Classic, in addition to the Bluetooth LE technology, which it had been supporting already since iOS 5. So back to your question. I looked at WWDC. There was nothing about Bluetooth, but there was something about the nearby interaction. So looking that up there, yes, the U1 chip that is available only from iPhone 11 devices, which is a bummer because I don't have one of those.
Neither do I. Yeah.
But it has some pretty cool technology. And I was trying to think of, is there anything actually relevant to anything that I do? Not really. But the technology is really cool. It does have a lot of limitations, though. So when I was looking at how it works and whatnot, it's very similar to the multi-peer connectivity framework. But it has some caveats that you need to be holding your phone only in portrait mode. And you have to be like back to back to the other phone, like the rear of your phone facing the back of their phone. So like the cameras are facing each other, although it has nothing to do with the camera. It is the UI chip.
Right.
So I keep calling it UI. Sorry. It's the U1 chip. It was really cool seeing the different ways that it could be used. And interestingly enough, and this I think is amazing, and hats off to you, Apple, is the simulators can use the nearby interaction framework, and it actually works. Like during the talk about the nearby interaction, it shows the use of two simulators and how the app interacts when they become closer and further away from each other, which I thought was amazing.
Nice.
And I wonder if that's
so it has like built-in mocking.
Something. I wonder if they're going to do some built-in mocking for Bluetooth. That's what I wanted to know.
Yeah. And I'm also curious if they're going to bring that to the iPad. I would assume so, or even the Apple Watch.
Right.
Because, yeah.
Although, what are you going to do with it? Let's say you had an Apple Watch with this framework. What are you going to do with it?
So is the idea to like be able to transfer data more reliably than Bluetooth? Is that their thought?
That's not what it looked like to me. To me, it looked more like gaming. That's kind of where I saw more of the application. And also it says it's only up to, I think 9 meters. But again, with the issues of obstructions, occlusions also will reduce the reliability of the data transfer. And interestingly enough, the information that you get from the other phone, if I remember correctly, you get the distance in meters, and you get the physics, and both the distance and the physics, the 3D vector, are both optional properties. And I thought that's interesting. Why are they optional? Isn't this something that's supposed to be?
No, I'm looking at the thing right now, and it's pretty much games and rideshare apps to know the user's direction in real time.
Right.
And that's pretty much it. Yeah, like you said.
Right. But I thought it was interesting that the direction and the distance were both optional properties, because they know that things aren't necessarily reliable. And if you're trying to communicate one device to the other, and then somebody walks in between them, so you might lose your direction, or if the person is out of the range, it's like a kind of like a cone shaped area that you get the information from. Yeah. But it definitely looked interesting to try it out. There's so many things, so many new technologies to be like, I don't have enough hours in a day. I'd love to try out everything.
Yeah, welcome to the club. So before we close out, I wanted to ask, where do you think Bluetooth could be used more often in iOS apps? And also, how is it currently being misused?
Well, Apple certainly pulled up its socks about Bluetooth abuse in iOS 13. And I don't know if you recall, but when you upgraded from iOS 12 to iOS 13, all of a sudden, a lot of your favorite apps were asking for Bluetooth always usage. And it was like, what?
Right.
What are you
And these
doing with
weren't
my Bluetooth?
Bluetooth
No,
apps
not
at
at all.
all.
Not connecting to a device. So what were they doing with that Bluetooth? So apparently, you could get a lot of location information from the user by using their Bluetooth. So that is an abuse of power. And Apple made it very clear that they're not going to have any of that. As soon as you instantiate a central manager, right away you'll get a pop-up that triggers the permissions for Bluetooth always usage. So that's one way I know of apps misusing Bluetooth. I can't really think of another way that an app would be misusing Bluetooth, because you really need to have the user's permission to connect to things. Usually connecting things, you need to initiate some kind of process.
Right. Right. I mean, one thing folks should look at is if they're using any sort of like analytical framework in their CocoaPods file
Yes.
or
Yeah.
whatever. Like, take a look at what you're using, because it might be using Bluetooth and like basically trying to match up data in order to track your users. So yeah, I would highly recommend be very careful about that kind of stuff if you're using any of that kind of technology. Is there any place? Go ahead.
I was thinking back that many years ago, when I was working at Glide, we once had an app that was rejected by Apple for using the advertising identifier. Like, the advertising identifier? We're not using the advertising identifier. And sure enough, as you said, one of the frameworks that we were using was taking the advertising identifier and not using it for advertising purposes. And that's why the app was rejected. So Apple is very strict about privacy, which I think is great and really good for the users. And therefore, nobody can sneak up and use your Bluetooth on you anymore.
Right.
But Bluetooth in general, I don't know if people are looking for more uses of it or are looking to newer technologies to replace it. Bluetooth, it's got a lot of pluses. That the fact that it's an old technology, it's been around since the 90s, makes it very well documented and perhaps more reliable. And one of the interesting things about the Bluetooth technology is that everything is backwards compatible, which is really cool. But I think that people are looking to different solutions. There's a lot more use of Wi-Fi. There's NFC. There's this new U1 chip. I think that people are still looking for faster, better, cheaper, more reliable solutions than Bluetooth. And I can't really think of a specific application that iOS is, missing out on using Bluetooth. But it's really cool to think about all of the technology that we all hold in our pockets all the time.
Yeah, it is really amazing. Is there anything else you wanted to mention before we close out?
Well, I think that going into something like, checking out Bluetooth can be very daunting for people if you've never tried it before. And there really is a lot of information. But one of the things about it is because, as I mentioned before, it's an old technology. It's also pretty old technology for Apple, being around for all these years. So it's very, very well documented. And even the things that are quote unquote problematic or non-intuitive, if you read Apple's documentation, you're gonna get all of it there. Like, for instance, the ability when you're scanning for peripheral devices, you have the option to scan and tell which services you're looking for, or you can just scan for anything that's advertising. So one of the things that perhaps is not intuitive is if your app goes into the background, you're going to keep scanning if you've set which services you're looking for. But for instance, if you didn't pass any services and you just said look for devices, once you go in the background, you're not going to get any hits. That's it. It just stops scanning. And so if you didn't know about that, it might be surprising. But again, it's all in the documentation. So I would definitely recommend that if you want to look into Bluetooth, it's really not so scary. And read Apple's documentation. Just read it and then try it out. Try it out.
Yeah. Thank you so much for coming on. We'll post some links to your talk from UIConf, as well as some of the tools that we've been using to help us. And then where can people find you online?
Well, I'm not really very active on my Twitter account, but I'm happy to answer over there. LinkedIn, I blog a bit on Medium. I actually have an idea for a new post, trying to figure it all out before I put it onto, I would say put it onto paper, but we're way past that. But yeah, so yeah, you can find me Medium, Twitter, LinkedIn.
Cool. And we'll have those links in the show notes. Thank you so much, Leah, for coming on the show.
Thank you for having me, Leo.
People can find me on Twitter at LeoGDion. My company is Bright Digit. You can find Bright Digit on Twitter as well at Bright Digit. Thank you so much for joining us for this episode, and we will be talking to you again. Bye-bye.
Thanks. Bye-bye.